Okay, so today we are going to see 2D motion in 2D. So if you see basic mathematics, laws of motion, 1D motion, work energy power, mechanical properties, gravitations have been done. Today we are going to see 2D motion, that is also very important, okay, projectile motion and all, okay. So motion in 2D. Projectile motion. See, one thing always you remember before starting this chapter, I want to say basics, little bit vector basics I am telling. That suppose there is one velocity, one object is moving in this direction. Okay, basics I am telling. Suppose one object is moving in this direction, making an angle theta with this horizontal. We can write its components. Components you are able to write. How to write the component? Like see, those who don't know, you see here. If this is the velocity now, you rotate towards theta, this angle. You rotate this vector towards this angle. So that will be cos component. Correct? Means this component will be cos component, means V cos theta. If this is V cos theta. And if this is V cos theta, the perpendicular component will be V sin theta. Correct? So first you should understand the components. Again, suppose the object is moving in this direction. You should be able to draw like its component, write its component. Suppose this angle is theta. Again, what I am saying, this velocity will have two components, one in the downward direction, one in the left direction. Now, how we decide why downward, why left? How we decide? See, after some time, the body is moving in this direction. No? After some time, from here, the body will be here. It went down and it went left. It means it has two components. One is this component and one is this component. Now, this is V, this is theta. Rotate the vector towards theta. Rotate the vector towards theta. That will be cos component. So this will be V cos theta. And this will be V sin theta. These things you should be able to understand. Correct? Vectors. Now what is the projectile motion? See, suppose you are playing football on the ground. This is the ground. And you kicked a football. Suppose there is a football here. You kick the football in this direction with some velocity V. Correct? Like we kick the like this. So this football will go like this. See here. This football will go like this. This is called the projectile motion or motion in 2D. Why it is called motion in 2D? Because it is going two dimension, means X and Y. When it is going in right direction, as well it is going up also. Correct? It is going in the right direction also. You can see the football was here. Finally, at some time the football will be here. This is the highest point. And finally the football is here. So when the football was there, we can definitely say now the ball has shifted to the right direction as well as it has shifted to the upward direction. That's why motion in 2D. Now if this is V and this is the angle that was made from the horizontal, from the ground, you kick the football with V velocity, making angle theta. So you have to learn things and how to apply things, that also you should understand. Correct? Like for example, If someone asks what is the time taken by the ball to reach to the topmost point, like we are going to solve these kind of questions, but 2-3 points you need to remember. Whenever there is motion in 2D, means you can see that x direction also the body is moving, y direction also the body is moving. What you have to draw? What you have to write? You have to write the equations x direction separately, y direction separately. Means if I say along the x direction, see we have three major formulas: v equals to u plus at, s equals to ut plus half at square, and v square minus u square equals to 2as. So see, we projected the ball with v. What is its speed in x direction? This direction. V, this is theta. So v cos theta. Correct? And what is its speed in y direction? V sin theta. So someone asked in x direction, what was the initial speed in x direction? So you will say v cos theta. Similarly, if I say what is in y direction, what is its speed? Y direction we will study separately. Speed in y direction, initial speed. So v sin theta. If someone asks what is the acceleration in x direction, there is no acceleration, not given. In x direction there is no acceleration. So acceleration in x direction 0. But someone asks what is the acceleration in y direction. So if you throw any ball up or any kind of thing, any object is always accelerated downward, like this object is at rest. But its weight, that g is acting downward, no? You know, this thing g always act downward. So acceleration in y direction is g. Correct? Now how to solve? They have asked how much time it will take to go to the topmost point. Time to go to the topmost point. Means if we focus on our A to B journey, suppose this is A, this is B. So time to reach from A to B. See, now when you are applying equation, x direction you apply separately, y direction you apply separately. For example, if I use this equation, v equals to u plus at, what I am trying to say, if you are writing x here, here also you should write x, here also you write x. Don't mix that here x, here y and all. Now, what is the final velocity? Like, see, object is moving like this. There is no acceleration in x direction. If there is no acceleration, you think like you are riding a bicycle or bike. If there is no acceleration, means your velocity will remain constant. This is the meaning of no acceleration means velocity will remain constant. Means in x direction, velocity was v cos theta. Initial velocity was v cos theta. See, initial velocity v cos theta, and acceleration is 0. Means in x direction velocity will all the time it will remain v cos theta. Understood? Means if the ball reaches here, for example, if the ball reaches at this point, here also x component velocity will be v cos theta. If the ball reaches the topmost point, here also x component velocity will be v cos theta. At this point also, x component of velocity v cos theta. And at this point also, x component of velocity will be v cos theta. It is not going to change. How y component will change? As you throw any ball, what happens? Its speed decreases, and finally it becomes 0. So y component will change. Here it is v sin theta. Here it will be something else. I am writing v dash. Here y component will become what? Topmost point, y component becomes 0. Here y component, if someone asks what is the y component of the velocity, y component at the topmost point, it will be what? 0. But if someone asks what is the net velocity at the topmost point, v cos theta, net velocity. Now as it fall down, again y component will increase. Here also it will increase, again it will increase, here it will be maximum. Now here also same thing. You remember 1D motion I told, I don't know you people attended or not. Same level, same speed. Same level, same speed. If the object is at the same level, na, its speed will be same. Like the speed, whatever is the speed of the ball here, same level means here also same speed will be there. So see, v cos theta, here also v cos theta. Here in the upward direction v sin theta, here only difference will be downward direction v sin theta. But value will be same. Always remember, whenever you throw any object, this was in 1D also. If you throw any object with 20 meter per second, it will go up, finally its speed will become 0, again it will come down and it will come back with 20 meter per second, same speed. Here you throw the ball with some v speed, x component v cos theta, y component v sin theta. Here same level, same speed, x component v cos theta, y component v sin theta. V sin theta. Net velocity in this direction, v. So these things you should remember. I asked this question, what is the time taken the ball to the reach to the maximum height? This is the maximum height from the ground. So if we apply this formula, you say final velocity in x direction. If you solve little bit, it will be complex. Correct? Not complex, you can solve. So final velocity in x direction is v cos theta. Initial velocity in x direction, v cos theta. See what is going to happen, v cos theta. Acceleration in x direction 0. So this will be 0. So v cos theta equals to v cos theta. You are getting nothing. They ask time to take, how much time it takes to move to the maximum. If I use this equation, see, so this is not working. If I use this equation, velocity, final velocity in y direction, v equals to u plus at. Now see what will happen. Final velocity in y direction is how much? 0. Initial velocity in y direction, v sin theta. Acceleration in y direction. So acceleration is downward, motion is up, body is going up, but acceleration is downward. So minus g. So minus gt. So this minus gt will come here. So plus gt equals to v sin theta. So time to go up will be v or u whatever, v sin theta by g. This is the time the ball takes to move to the maximum height. Correct? So this is how we solve in x direction and y direction. Like someone asked another question. What is the maximum height reached by the ball? Maximum height reached by the ball. You know, you remember this formula? H max. What is the maximum height reached by the ball? Physics you have not studied. 1 year I understood. See, H max, we are talking about maximum height, means we are talking about y direction now. So again, if we write, see, final velocity in y direction, v square minus u square equals to 2as. So final velocity in y direction is 0. Initial velocity in y direction is u sin theta. So u square sin square theta equals to 2. Acceleration in y direction is minus g. displacement in y direction is suppose h max. We are talking for A to B journey. A to B journey. A to B journey. A to B. So what is the displacement in y direction? See now in y direction how much it got displaced. So this is what h max. If you solve this again minus minus cancel. So u square sine square theta by 2g. This is h max. Correct? So don't worry, I will give you, I know that if you now you solve like this, it will take a lot of time. I will give you what are the important things that they ask from this. See, important things. Always remember, if you are kicking one ball and it is going like this, correct? This is A, this is point B, this is the topmost point, this is the point C, correct? You have kicked the ball with V velocity or U velocity, making an angle theta with the horizontal. This always remember. Sometimes they confuse. What they will do now? They will give that you are throwing one ball with U speed, making an angle theta here. This angle they will give, and you will apply the formula, you will get the wrong answer. Always remember theta we always take from horizontal. Now what are the points to remember? First, time to go up means A to B. Suppose it is taking 4 seconds to go from A to B. 4 seconds it will take to come down. So time to go up is called time of ascent. Time to come down is called time of descent. So first point, time to go up, time of ascent is equals to time to go down, and this is u sine theta by g. Just now we saw u sine theta by g. Correct? Next, time of flight, capital T. Okay, what is this? Time of flight means how much time the ball was in air. This is called time of flight. So time to go up plus time to go down. This much time, no? Means this time plus this time. Means time of ascent plus time of descent. And both are same, u sin theta by g plus u sin theta by g. So 2u sin theta by g. 2u sin theta by g. This is the time of flight formula. 2u sin theta by g. Next, always remember, same level, same speed. Same level, same speed. Next, maximum height reached by the ball, h max. Just now we saw what is h max. This is h max. U square sine square theta by 2g. Correct? This is the maximum height. One more thing they ask, range. What is range? Means you throw the ball from here, it landed here. This distance is called the range. From here to here, this distance will be called range. Correct. Range formula. U square sine 2 theta by G. U square sine 2 theta by G. Or sine 2 theta, you can write 2 sine theta cos theta. So U square sine 2 theta, you can write 2 sine theta cos theta by G. This is the range they ask. Then they ask when this range will be maximum. Achha, when this value will be maximum. They ask when range will be maximum. Speed is same. At what angle you should throw so that the range is maximum. So maximum value then you will get. When sine 2 theta value will become 1. You know na, sine theta maximum value is what? 1. Means this sine 2 theta value should be 1. Means 2 theta should be 90 degrees. Sine 90 degrees 1. So see, range maximum. What is the condition for range maximum? For range maximum, 2 theta should be 90 degree or theta should be 45 degree, 90 by 2. Sine 2 theta 90, 2 theta 90. So sine 2 theta 1, so 2 theta 90. So theta 90 by 2, 45 degree. So if theta is 45 degree, range will be maximum. Achha, maximum range. If they ask what will be the then maximum range? So U square sine 2 theta, sine 91 by 2G. This is the maximum range. When it will happen? When theta is 45 degree. One more important point. From the ground, this is the ground, whether you project the ball from theta or you project the ball from 90 minus theta, whether you project the ball by angle theta, by same speed I am talking obviously, here also speed should be same. If you project the same ball with same speed but at an angle 90 minus theta, for both these cases, range will be same. Range is same. What I might mean to say, that if you project any ball with some speed, u, here also in this case also you are projecting with same speed u, whether you project with theta, suppose for example I give 30 degree, or you project the ball by 90 minus theta, 90 minus 30 is 60 degree. In this case and this case, in both these cases, range will be same. You will get same range. Range same. Very important point. Correct? I don't know how many of you remember. Many people don't know this. So range will be same. See, last, like this, see, you can see this is not a straight line. This path is not a straight line. This is called projectile. What is the equation of projectile? If they ask what is the equation of projectile motion, equation, always remember y equals to x tan theta 1 minus x by r. This is the equation of the projectile motion. Y equals to x tan theta 1 minus x by r. Correct? You must have seen like this also. Y equals to x tan theta minus gx square by 2u square cos square theta. This can be written like this also. Y equals to x tan theta minus gx square divided by 2u square cos square theta. This is the equation of projectile. Okay. Means what is these things? X coordinate, y coordinate. Y is y coordinate, x is x coordinate. Theta is what? At what angle you throw the ball. R is range. See, every point, what I am saying, every point must be having, na? Like for example, this point. It must be having some x coordinate. It must be having some y coordinate. So these 2 points will satisfy this equation. These 2 points will satisfy this equation. Okay. Like one question I am saying. What will be the height of football when its x coordinate becomes 1/3 of range keep theta equals to 45 degree. This is the question. What will the height of the football? Height means y coordinate they are asking. And this distance means x coordinate. When its x coordinate becomes 1/3 of range. So you can apply now this equation. Y they are asking equals to x coordinate is 1/3 of range. So r by 3. 1/3 means what? R by 3. Tan theta. Theta they have taken 45. So tan 45 degree will be 1. Tan theta. Theta is 45 degree. So tan 45 degree 1. 1 minus x coordinate. Again x coordinate they have told how much? 1/3 of range. R by 3. R by 3. By R. By R. So range gone. So y equals to R by 3. Tan 45 degree is 1. 1 minus 1 by 3, that is 2 by 3. So this will be 2r by 9. This will be the y coordinate. So they can ask question from here. Equation of projectile. That if this is the x coordinate, what will the y coordinate? Use this equation. You will get the answer. Okay. Okay. See. River boat problems. River boat. You remember river boat? Not studied? So suppose there is a river. It is flowing like this. Suppose the velocity of the river is in this direction. This is the velocity of river in this direction. There is a person here. Correct. He wants to go to the shortest path. He wants to go in shortest path. Two types of question comes. Shortest path and minimum time. Shortest path. He wants to cross the river via shortest path. So you tell me, if the man tries swimming here, will it go there? Will it reach there? No. Why not? See, river water is coming now with some speed, velocity of river. So what will happen? It will tilt this. The man will follow basically this path and this man will reach here. You can understand? That suppose I am moving here and water is coming like this. So I will get tilted now and I will reach there. Understood? So, in order to, again proof and all I am not doing, in order to reach to the shortest path, man has to basically move in this direction. Correct. Now if the river water, like suppose this is like this, now if it tilts, so it will be straight. You feel now? So the effort you are trying, wherever you are trying to swim, like you have to try to swim in this direction. This is called velocity. Always remember, velocity of man or boat, whatever. Velocity of man with respect to river, VMR I am writing. Velocity of man with respect to river. Whenever you are trying to swim or wherever you are steering the boat, that is velocity of boat, not velocity of boat, velocity of boat with respect to river. So what will happen actually? If someone is from the ground, see, if someone is watching all these things from the ground, he will see that water is tilting this. Water is coming like this, it will hit and it will become straight like this. Okay? Correct. So someone from the ground will say na, that the man finally moves in this direction and he will reach this point. So this is the shortest path, shortest. So this will be the final velocity of man. Correct. Now this figure just you have to remember. What you have to remember? Rest all questions you will be able to solve. This you have to remember that this is the velocity of man and this is VMR. And here if I write, see, try to understand, this is velocity of man, this is velocity of man with respect to river, and suppose this vector, if I reverse, this is velocity of river now, so this will be what? Minus of velocity of river. Correct? This direction was velocity of river. If I reverse, this direction will be minus of velocity of river. This diagram you just have to remember. All the questions they ask from here only. What questions they ask? How much angle the man has to swim so that it follows the shortest path? This theta they will ask. How much angle from vertical the man has to be tilted, or the man has to, like, see, I have to go straight, but due to water, definitely I will have to move in this direction so that water hits me and I am moving in the straight direction. So they will ask, what will the angle? Theta. So one thing what we can say, VMR, see again that thing, this is vector, you rotate it towards theta, you get cos component, means VMR, this is theta, So this will be VMR cos theta. Means what we can say, what I am saying, see again, hide this. This is VMR, this is theta. If I rotate towards theta, we will get cos component, VMR cos theta. So VMR cos theta, you can write VMR cos theta is equals to VM. One component in this direction and one component in this direction. Similarly, VMR sin theta, value, just I am focusing on value. So value will be VR. Minus is just tells, for vector quantity, minus just tells direction. Right now I am concerned about just the values. So VMR cos theta, what I am saying, this vector has two components. One component in this direction and one component in this direction. Hide these two. So this is VMR, this is theta, this is VMR cos theta, this is VMR sin theta. So VMR sin theta is nothing but VR, no? VMR sin theta is nothing but VR. Just you have to remember this. They will ask question from here only. Just they will give the values. Rest all the things is these two equations. So remember this diagram and remember this formula. No need to mug up. If you just remember this diagram, then you can form na VMR cos theta equals to VM and VMR sin theta equals to minus VR. Correct. Next question, what they ask, shortest time or minimum time. If the man has to cross the river in minimum time, what he should do? See, again I am not going for the derivation, again I am saying, you just remember, if the man has to cover the shortest time, this is the velocity of the river. If the man has to cover in the shortest time, now the man has to move in this direction. Means the man has to swim in this direction. So what I am saying, this is the velocity of river and the direction in which man tries swimming is what? Velocity of man with respect to river. But what will happen? Due to the flow of river, the man will move in this direction. So this is the velocity of man. This is the actual velocity of man. Correct? So man has to try swimming here. Due to the flow of river, man will move this. So this is the velocity of man. And finally the man will reach, you can see this point. So suppose this is the angle theta. What things we can write? First, this is Vm, you rotate towards theta. So it will be Vm cos theta. So Vm cos theta is equals to VR. See, Vm, this is theta, Vm cos theta is equals to VR and Vm sin theta will be equals to VMR. Vm sin theta equals to VMR. Correct? So this is the first thing they ask. So you should remember this diagram. This diagram you should remember. Okay? See, whenever they write this statement now, that velocity of man or boat, whatever, in still water, always remember, this is not velocity of man. If you write, this will be wrong. This is basically velocity of man with respect to river. If they use this statement, this is just English. So this is velocity of man with respect to river. If they ask, the velocity of man in still water is this, they will give in the exam, the velocity of man in still water is 20 meters per second. So that is basically velocity of man with respect to river. Correct? Now what question they ask? So if they do this now, if the man tries swimming here, man will finally follow this path, but it will reach in minimum time. Always remember, the time will be minimum. They ask that, see, man intention was to go here, but finally man reached here. So this distance is called drift. This distance is called drift. So they will ask, what is the drift? This. And they will ask another question, how much time it takes to cross the river? Achha, they will give the width of the river. They will give the width of river. Suppose width of the river is W. So they will ask two questions. First, time to cross the river. Time to cross river. So crossing the river means going from this side to this side, means we are concerned about y direction. So time, can I write time equals to, see, there is no acceleration and all in this case. There is no acceleration and all in this case. So time equals, speed equals to distance by time. Time equals to distance by speed. But because we are concerned with y direction, so distance in y direction, the man has to cover divided by what is the speed in y direction. So what we can write, time equals to distance in y direction. How much distance it has to cover in y direction? W, width of the river, divided by speed in y direction. In y direction, what is the speed? VMR. VMR or Vm sin theta. So you write VMR or W divided by Vm sin theta. Vm sin theta. This question they ask, how much time it will take to cross the river. So what is the basic funda? Distance in y direction is speed in y direction. Distance in y direction is W. What is the speed in y direction? VMR. In y direction, this is the y direction. What is the speed? VMR. So VMR. Achha, what is VMR from here? Vm sin theta. That's why I have written Vm sin theta. Now they will ask how much it got drifted. Drift. Drift means they are talking about x direction. So displacement in x direction. Can I write distance equals to speed into time? Speed in x direction multiplied by time. So speed in x direction is how much? VR. In x direction, this is the speed. This is the x direction. This is the speed. VR. So this you will write VR into time. Time we calculated, not this time. Achha, what is VR? VR we can write Vm cos theta. We can write like this also. Vm cos theta into time. This will be the displacement in x direction, or this will be the drift. Okay. So they ask from here only. Rain, man problem or boat problem. Okay. Next is, see, rain man problem. That was river man. This is rain man problem. Correct? Rain man. See, suppose rain is raining like this. So what do you write? This is the velocity of rain. And you are standing or you are sitting like this. This is the ground. So rain will hit vertically on your head. Correct? Now what do? You start running. You start running, or you start your bike and you move with high velocity. Now what you will feel? The rain comes to you little bit slant. So when you start running, suppose you start running in this direction, this is the velocity of man. What? See, this is the velocity of man. There you are running. What was the velocity of rain? Velocity of the rain was in downward direction. This was the velocity of rain. If someone asks, what is the velocity of rain with respect to man? Velocity of rain with respect to man. With respect to man, how rain is coming? When I am, suppose, driving a bicycle or bike, so with respect to me, how rain is hitting? Actually, rain is going down only. Actually, rain is, but when I am driving, so how it is going to hit me? So see, so that is velocity of rain with respect to man. Acha, we know that in 1D motion I have told, velocity of A with respect to B means velocity of A minus of velocity of B. So velocity of rain with respect to man means velocity of rain minus of velocity of man. So this is velocity of rain minus of velocity of man will be like this. This will be minus of velocity of man. Means basically you have to add these two vectors. VR vector plus minus VM vector. Means VR vector plus minus VM vector. So if you add these two vectors, see, if you add these two vectors, so what will happen? The resultant will come in this direction. The resultant will come in this direction. That's why rain, you feel that rain is coming in this, slightly this direction. So this will be velocity of rain with respect to man. So rain is coming in this direction. That's why sometimes they ask, with what angle you should put the umbrella? At what angle you should put the umbrella? This kind of question they ask. So rain is coming in this direction, means you should put the umbrella. Suppose this is the umbrella. You should put the umbrella in this, like this. Suppose this is your umbrella. So your umbrella should be like this. Correct? So they will ask this angle, that form vertical, how much angle? Like suppose this angle is theta. At what angle you should tilt the umbrella? So if this angle is theta, so vertically opposite angle, this angle will also be theta. See na? This angle theta, so this angle will also be theta. So what equation we can write? This is VRM, rotate this vector towards theta. This is VRM, rotate this vector towards theta, you will get cos component. Means VRM cos theta. VRM cos theta is equals to VR. And VRM sin theta equals to minus VM. VRM sin theta equals to minus VM. Magnitude if I am saying, so you can write VM. Just I am talking about the values. So by solving this, you will get the answer. Whatever they ask, rain problem will be solved from here. The thing is, you have to remember this diagram. No need to remember this formula, just this diagram you remember. Rest you can form now. This is VRM, this is theta, rotate. This component will be VRM cos theta, and this is VR. And this component will be VRM sin theta. This is VM. Minus VM, but ignore the direction. Value will be VM. So this is rain man problem. Correct? See, sometimes other kind of questions I am giving. Like they give that position of the object is t square plus 4t plus 5. Y coordinate t cube plus 4t square plus 5t plus 8. Correct? Then they ask, what will the net acceleration of the object? Correct? See, first find velocity of the object in x direction. Velocity of the object in x direction. So velocity in x direction dx by dt. So differentiate this. So t square differentiation will be 2t, 4t differentiation will be 4, 5 differentiation will be 0. Achha, what will the acceleration in x direction? Acceleration is what? dv by dt. So differentiate this, 2t differentiation will be 2, 4 differentiation will be 0. So acceleration in x direction is you are getting 2. Similarly y, what is the velocity in y direction? Differentiate this, 3t square plus 8t plus 5, 8 differentiation is 0. What is the acceleration in y direction? Again you differentiate, 6t plus 8 plus 0. And they are asking the question that at time equals to 2 seconds, you have to tell what is the acceleration of the body. So acceleration in x direction is constant, that is 2. Acceleration in y direction 6t plus 8. So in time equals to 2 seconds, 6 to the 12, 6 to the 12 plus 8, that is 20. So net acceleration will be under root acceleration in x direction square plus acceleration in y direction square. So acceleration in x direction, that is 2 square, that is 4, plus acceleration in y direction, that is 20, 20 square, 400. So under root 400, 4. Correct? This clear? This kind of question they ask. Okay. So one more topic I will tell you. Okay. Friction. That is also very important. Friction. So you write the topic, means, okay, if you want to listen, you can listen. Friction. Correct. So see, what is friction? Friction opposes relative motion. Friction is something, not going in much detail, which opposes. Achha, some people think na, that friction opposes motion. No. That's why I have written this word. Friction opposes relative motion. Some students think that friction always opposes. No, friction supports. We are walking, na? It supports the motion. Why we are walking? Suppose we are walking, friction is in the like forward direction. Correct? One more example I want to give. Suppose this is the book, this is the mobile. If I am pulling this book, like this, mobile is also coming. Correct? If I am pulling this book, see, this is the mobile, this is the book. I applied force only on the book, na? I am applying force only on the book. I am not applying any force on the mobile. But if I am pulling like this, mobile is also coming. But I didn't apply any force in mobile. So how mobile is coming? Because there is friction. Friction is helping it to move. So friction is not, don't think that friction always opposes the motion. It also supports the motion. but it always opposes relative motion. You will see. Like here we have seen now that this object is coming because there is friction. Correct. So sometimes friction supports the motion also. Correct. If this object was made of ice, think, or this object was made of ice. Ice means very smooth, almost negligible friction. Suppose this was ice, and if I would have pulled, so this would have slipped. You can feel now, slipped. So why in this case it is coming? Because this is rough. There is friction, and friction is helping to move. Acha, always remember that suppose there is a Almira kind of thing, or one block, huge block, one table I wanted to write. This is how much force you are applying. This is how much friction it will have. And this is the condition of the object. So suppose this is very heavy mass, some Almira kind of thing. Suppose you applied some force from here, you tried to push. Suppose, initially there is no force. No force, friction also 0. Now you applied force 1 Newton, but the object is not moving. Correct? Suppose like this, I apply force little bit, it is not moving. I have to apply more force now. Like this bench, I am applying force, it is not moving now. See why? Because friction is opposing. So you are applying force here, friction is opposing here, opposite direction. That's why the object is not moving. What you saw, again now the object is not moving. Here means friction must also be 2. Similarly, when you apply 10, what you thought, what you found basically, that still the object is not moving, but it is just on the verge of motion. Just now it will move, but it is not moving, means friction is 10. Means here the body is at rest, here also rest, till here the object is rest. Every person has maximum limit. Means suppose I am trying to go, suppose there is a small boy who is trying to oppose me, don't go. But it will have some maximum power, na? Maximum limit. If we cross that limit, that boy won't be able to stop me. So suppose this was the maximum limit of friction. This is the maximum value of friction. Correct? Now if further you apply force, suppose 12 Newton, how much it will apply? It will apply maximum only, na? 10. Now the object is in motion. Again, if you apply 14 or 20, whatever, how much friction will apply? Its maximum 10. And the object will be in motion. But what has been seen, very important point, what has been seen, as the body moves, these last two cases, as the body moves, you can think like this, friction gets little bit demotivated because it was trying to oppose me, that don't move, like think like a small boy trying to oppose me. Now if I cross, he still is applying 10 only, but now he gets little bit demotivated, so little bit less than 10. So always remember, when the object is in motion, friction applies maximum but little less. Means here I can write little less means 9.9 something, 9.8, 9.8, and rest 9.8 will be fixed. Means this value is the maximum value of friction. So friction maximum value here, if someone asks, it is 10 and here the object is at rest, so that is called static friction. Static means rest. Later on, when the object is in motion, then someone asks what is the friction value. So friction value will become constant, 9.8. This is slightly less than this, and this is called kinetic friction. Kinetic friction. From here, what you can see, when you are increasing force, friction is also increasing till it reaches maximum, and thereafter friction decrease, a little bit decrease. So if I draw the graph, so the graph is like this. This is the force you are applying. This is the friction, this side friction. So force is 0, friction is 0. Force increases, friction increases. So it is a linear graph, straight line. Y equals to x, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Till friction reaches maximum. This is the maximum friction, 10. So we can write like this. This is the maximum friction, F max. In the example, we took 10 Newton. Then what happens? As the now this was the maximum capacity. Now the body will move. Now when the body moves, friction little gets devoted. Little bit less value it has. Little bit less. Correct. So friction decreases little bit. Little bit. Okay. And this is kinetic friction. If I say this, what is this point? Kinetic friction. Or Fk I am writing directly. Fk. So this graph is important. This graph is very important. This is not going up. This is stable, straight line. This is stable and straight line. Okay. Correct. So see, what I am saying, one thing you need to remember, friction formula, friction maximum formula, friction maximum formula, friction maximum is, always remember, directly I am writing mu s into n. Mu s into n. What is n? Normal reaction. And what is mu s? Coefficient of static friction. Coefficient of static friction. Static friction. This is the maximum friction. Means here the body is at rest. Here the body is at rest. Now when the body is in motion, then Fk, kinetic friction, and its formula becomes mu k into n. Like this is mu s into n. Now s means static. Static means the object is at rest. Mu k into n. Object is in motion. Here the object is in motion. So if the object is in motion, you have to apply this formula. If the object is at rest and friction is applying maximum, then you have to use this formula. Always remember, this kinetic friction is a little bit less than static friction, little bit. Static friction maximum value means mu k into n is slightly less than mu s into n. N you can cancel. So always you will see now that mu k is little bit less than mu s. Okay. 5 minutes more I will take, because this friction is important. Now see, 2-3 points you should understand. One is like, see, there is an object. What are the forces acting on it? So one force is mg, one force is normal, and suppose the object, someone applied force, so friction, suppose someone is applying force in this direction, and the body is on the verge to move, means right now it is not moving, but it is on the verge to move, means friction is maximum at that point. So this is F max. Suppose this is friction, F max. Correct? Then what we can write? See, this normal reaction at F max resultant we called R. This normal reaction and this friction max resultant we call R. Correct. R is the resultant of normal and friction maximum. What is R? It is the resultant of normal and friction maximum. Now this angle that R makes with normal, the angle that R makes with normal, suppose this is phi, this is called angle of friction. Angle of friction. Angle of friction. Correct? Acha, can I write R cos phi? R cos phi equals to N, and R, this is cos theta and this is sin theta. R sin phi equals to R sin phi equals to F max, and F max we know how much, mu s into N. This is the maximum value of friction. If I divide these two equations, R will be cancelled. So tan phi equals to, this N will be cancelled, equals to mu s. Always remember, tan of angle of friction equals to coefficient of static friction. Very important point. Tan of angle of friction, phi is angle of friction, equals to coefficient of static friction. Okay. Last point. Angle of repose you must have heard. Suppose this is inclined plane. This angle is theta. And there is one block or there is one ball like this. Okay. Initially the angle was less, ball was not moving. You increase the angle, still the ball is not moving, going down. You increase more, still the ball is not going down. At this position, the ball just tends to go down. Just, it is not going down, means now it is going, it little bit extra you will give na angle, the ball will fall down. So this angle, this theta, till the ball remains at rest, this angle is called angle of repose. This theta is called angle of repose. Angle of repose. That maximum angle so that the ball does not slide. Maximum angle so that the ball does not slide down. We have to find this angle. See, what are the forces acting on this ball? One is normal. This side mg sin theta. We all know. We have studied this. You can see the lectures also. Mg sin theta. This side will be mg cos theta. Just 2 minutes I will take. Mg cos theta. And since the ball is not sliding, means friction is there in the opposite direction. Here friction. Ball is not sliding. Means whenever ball is trying to slide, friction is opposing. That's why. So this is friction maximum, F max. Now what you can write? mg sine theta, because the object is at rest, equals to F max. Equals to F max is how much? Mu s into n. And normal equals to mg cos theta. So mg cos theta equals to normal. Again if I divide, so mg cancel, sin theta by cos theta, that is tan theta, equals to n cancel, mu s. See, almost same kind of formula. Tan of angle of repose is also equals to coefficient of static friction. So remember 2 points, this is very important. Tan of angle of friction is also equals to coefficient of static friction, and tan of angle of repose, this is also equals to static friction. What is angle of repose? Maximum angle till the ball does not slide down. This theta is the angle of repose. So go through all these points. Okay. Very important points. Learn the formulas. Questions will come. 90% question will come directly. Not all the question I am saying, but 90% will come directly. You have to just, I have written these formulas, now you have to place the values. This is the only difference in NEET, what I am explaining. Okay? Okay, thanks a lot.